Yes, let's look at what we call number formats in grade 10. Number formats, we are looking at how numbers are written. All right. In some countries, a decimal point is a comma in South Africa, whereas when they are separating thousands, they use commas. Those are other countries, all right? Instead of you writing 2.5, they would write it as 2.5. Then instead of you writing 4,800, sorry, instead of you writing 4,850, 550, then for them they will say 4,58. The comma is for thousand separators, and the dot is for the decimal. All right. When we look at this, you know very well that thousands are separated every after 3 numbers from your right-hand side. Right-hand side. So, for example, look at question number 1 here that we have. Write the following numbers with 1,000 separator. That means we're going to put commas whenever we see 3 numbers. So this would be in 1,000 separators. We are using 1,000 separators. We shall use a comma here in other countries, and we shall use space in South Africa. All right, I'll start with South Africa. So for 3, every 3 numbers, so here we are going to leave a space. We shall leave a space, and we shall leave a space here. So we shall write 2, leave a space, 350, leave a space, 988, leave a space, and 39, leave a space. This is how it's written in South Africa. So in other countries, it would have been 2, comma, then like that. This is in other countries. All right, let's separate this one. We said if you have 3 numbers from your right-hand side. So we have that. We come to that. We shall come to that. We have that. So simply meaning in other countries, it would have been 44. Sorry, that's South Africa. It's 44. Leave a space as 1,000 separator. Then leave another space after writing those. Leave another space and leave another space. In South Africa, these spaces represent thousands. And in other countries, this would have been 44,59. All right. And this will lead us to how to write numbers. This is how it's supposed to be. So we look at, let's write, I'm writing 1.3 here, this one here. 1,000 separators. So this means comma, so it's 4,284,61. So in other countries, it would have been, it's the same, however, people use different signs to separate thousands. Okay. So that is it. Then we look at 1.4, the other question. All they're asking us to put separators. So now when you look at it, we shall separate every after 3 numbers or from your right-hand side. So this is it. We have 1,234,567,890. This is how we do it. And in other countries, we put commas every after. That's what I want you to know. So come back here. You say in South Africa, space is 1,000 separator. 1,000 separator. 1,000 separator. And other countries, they would write it as, okay, they use what? A comma. Okay, another thing that you have to know is to change the format. For example, if the number is, let's say 7,54 million, to change it into numbers, all we have to do is to multiply by a million. In that we remove this word million. So if you multiply by million, that means 2 zeros have to go off because you have 2 numbers after the comma. So you remain with 7,540,000. So it becomes 7,554,000. Because the 2 zeros have gone, remain with 4 zeros, and these are the 4 zeros. So in other country, they would write it as 5. So this is South Africa, and we are saying this is for other countries. All right, changing the number format. So in South Africa, and in the other countries, it would have been a decimal place, a decimal point, sorry. In other countries, it would have been 7.54 million. Still, to remove the word million, you're supposed to multiply by the number million, in that this word disappears. Okay, that's number format. Decimal points / commas. That's how they work. Okay, let's continue with another question. Let's look at negative and positive numbers. A positive number, it should have a plus in front of it, or it should have nothing. You understand? Positive numbers. All right. Whereas a negative number will always have a negative in front of it. There's no any other option. So this is positive. That's how we usually write it, or you can write the word in full. Then we have this as negative, or you write it in full, negative. What you have to know is that the bigger the negative, the smaller it becomes. For example, negative 40 is less than negative 5. So, in other words, negative 5 is greater than negative 40. All right. Then another thing, where do we find negatives? Negatives, we use them to represent a number that's going below negative. If someone tells you the room is in negative 4, 2, that means it's below. It's in the basement, 42 fourth floor, but going downwards. All right. This simply means going down. All right. Whereas positive, it's going up. All right. We can also use negatives. Now, even if they are used in banks, all right? Banks whereby if you have a negative balance, simply meaning you owe the bank. All right. Whereas if you have positive balance, you don't owe. You have some money. You have some money. This is when we look at the banks. All right. Here, negative, you do not You do not have money. You don't have money. That's negative balance. All right. Then another thing that we shall look at it in terms of balancing, in terms of freezing point, minimum and maximum. We are saying maximum, minimum, maximum is a positive one, and minimum shall go to the negative. Then when you look at it in the terms of freezing point, the freezing point is it's 0 degrees. So if they say below the freezing point, that means you're in negatives. This is the freezing point. This is called a number line, right? The right-hand side, these are positive numbers. These are positive numbers. Coming this side, these are positive numbers. They don't have any sign in front of them. Whereas from this other side, we are saying these are negative numbers, all right? They have a symbol in front of them. Then we are saying freezing point, freezing point is this 0 here. Water freezes at 0 degrees, all right? Water freezes or water becomes solid at 0 degrees. We shall see what it simply means, and we see. So another thing that you have to know is that if you have a negative number plus a positive number, this one's the same as 4 minus 5. And the answer, now because 4 is smaller than 5, and yet you're subtracting, that means you remain with a negative number. This is so different, whereby if someone had a positive 3 plus a negative 2, this is the same as 3 minus 2, because this negative here has affected the positive. So this one becomes 1. Why? Negatives, we take them to be dates. We take them to be dates. All right. So if you have a date of 5 rand and you happen to get 4 rand, okay, or you pay 4 rand, how much are they still asking from you? It's a 1 rand. Whereas if you had a date of 2 rands, you happen to get 3 rands, how much will remain in your pocket? You remain with the 1 rand. Okay. So now another thing, how do we use a number line to solve such problems? So this simply means you can do it that other way. We said it was negative 5 plus 4. So this simply means you're at negative 5. You have to move 4 places. So we have 1, 2, 3, 4. You see that you get a negative 1. You understand? You get a negative. Or if you start from the positive side, it's 4, but you have to go how many times? 5 times on the left-hand side. So that means it's 1, 2, 3, 4, 1, 2, 3, 4, 5. You are moving 5 times on the left-hand side of 4. That's how we use a number line. Another one that you would see, let's take this other one here, 3. So we are at 3. You need to move 2 places to the left. So we say 1, 2. You see where you are. That's how we usually use a number line. Let me do that one of 3. We are saying we are at 3. 3 is positive. Move to 2 places from 3. So we have 1, then 2. All right. That's how we do it, or that's how we use negatives. Sorry, that's how we use a number line. All right. So this one could be at the moment, this is the maximum, and this is the minimum. This value here, it's the lowest value. Remember, I told you the bigger the negative number, the less value it has. For example, negative 1,000 is way smaller than 2. That means you're in debts of 1,000 rand. Someone who has 2 rand is better than you. You see that? Okay, we go on and we look at question number. Sorry, here we have some questions. Yeah. The temperature on a certain day in Karen is 7 degrees below freezing point. How would you write this temperature using numbers? Now, definitely, they're telling us below. Below the freezing point, we said these numbers are below. And these other numbers, these ones are above. So, below the freezing point, in this one, how would you write it? It would be, you start with a -7. If the temperature in on a winter's day is -5, and the temperature rises by 8, you see that? Determine the maximum temperature for the day if it rises. So now it was at 5. It's going to rise how many steps? 8 of them. So we start 1, 2, 3, 4, 5, 6, 7, 8. So this is the maximum temperature. You understand? So here we shall say it rises and it comes to 3. We've moved 8 places. Here we have 1, 2, 3, 4, 5, 6, 7, 8. Where the 8 ends, we take that number. Others would have used, you can use your calculator there, or you do 8, 5, 8 rises by 8, so we add on 8. This is the same as 8 minus 5, and the answer becomes 3. All right, 1.3, this was 1.2. 1.3, look at question number 1.3. 1.3, it says, the temperature on a cold winter's day is -3. The temperature rises to the maximum of 8. By how many degrees did the temperature rise? You understand? It rises to the maximum of 8. By how many degrees has the temperature risen? So it's at 8 here as the final answer. So it has to go up to -3. So what we're going to do, we are finding out. They have not told us by how many degrees has it risen, but they've told us the final answer. Take note of that. Yeah, in question number 1.2, take note. It says, or it told us, the temperature rise by 8. Now, the question is asking us, the temperature rises to the maximum here, 1.3. It's telling us to the maximum. The temperature rises to the maximum of 8. That means the final answer is 8. So from negative, so we are going to say from 8 here, we need to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Why am I stopping here? Because it was at -3. Then it has become 8. By how many? So we are seeing that it has risen to, or it has rose by 11. You understand? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. All right, because yeah, this is sample, meaning it's 3 plus a certain temperature, and they got the answer as 8. They got the answer as 8. So what do you do? Now, when a negative number jumps the equal signs, it becomes a positive. So it becomes, when the 3 jumps over the equal signs, it became a positive, and we just adding and becomes 1. Okay, that's the question. All right, we got on and we see question number 1.4. The maximum temperature on a certain day in Bethlehem was 12 degrees. If the minimum temperature was -5, determine the difference between the minimum and the maximum temperature. Now, determine the difference, simply meaning, remember in mathematical literacy, difference means subtraction, which would have been 12 minus 5. So minus becomes a positive, which gives us the answer as 17. And we cannot use, let me see, minimum was negative. Then the maximum was 12, somewhere there. So simply meaning we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 to make 11, 17 to make 12. Take note of that. What is the difference? What is the difference? So the difference is 17. A lift, an elevator, starts in the basement below the ground and moves up 7 levels on what level? On what level will the elevator stop? It starts from in the basement below and moves up 7 levels. At what? It will stop at probably they never told us at which. Okay, but this is say we shall cancel. It can stop on the 7th floor. Or the 6th floor. I'm thinking of the 6th floor if it began with 1, like 1 level. Because they're saying it's starting from the basement. So 1 level off the 7, making it what? 6. An elevator starts at the 5th floor and goes down to 3 levels underground by levels, by floors. And goes, So here, this one's sensible. We are saying 5th floor. So it's at this level here. It goes down 3 levels. 3 levels. So it's at the 3rd floor, the 3rd level under, which is a -3. Which is a -3. The table below shows the bank balance of 4%. Study the table below and answer the questions that follow. Remember, I told you this, it's almost 0. This is almost 0. However, this one is better than this one here. You understand? This one is better than this one. Okay, identify the first person owing the bank the most. So it's person number 2. Then write down the bank balance for persons 3 in words. Persons 3, this is the bank balance in words. So what we're going to write, first and foremost, we see 11175, but that's not the answer. Why am I writing it? I'm finding it to separate the thousands. So we shall say the answer there, 2 point. Another thing that I would like you to know, you can write from ones, tens, hundreds, then ones, tens, 100. That's like that. But however, the first part that we have, this is the normal number. Then these become what? Thousands. So when we come and say 11 is here. 1 is there, 7 is there, 5 is there. This simply means it's the 11 is under 1,000. So we shall say 11,000, 11,100, 170. Why am I saying 70? Because 70 is in the place of, it's in the place of tens. 75. 5 remains because it's in the place of ones. All right, another way you would have done it is to say, let me see, we have 1,000, then the normal ones, so this is 1101, 1, 1, 7, 5. You can write their values. This is 11 will go hand in hand because it's already in thousands. So this is 11. This one becomes 0, 0. This one becomes 01. This one becomes 7. This one becomes what? 5. So 11 what? Thousands, because it has 3 numbers after. So this becomes thousands. Already 11 is in the place of thousands, by the way. Then this is 1. 1 is under the, so it's 100. Then 10, the T stands for 10, which is, we have 70, and we have a 5. So from here, turn this into words. After you have written it. Okay, we look at the other question which says, or which asks us to say, which person has the most money in the bank? So here, the most money, we look at the person with the biggest number, the positive number, which we shall say, the person with the most amount of money here is person number 1. Remember, they have told you which person, they didn't say which, how much. So we shall say person 1. Okay, this takes us to the next section. The next section, this one you need, we need your calculator here, but you need to know operations. Operations, this is where you're talking of the plus sign, the division sign, the subtraction, and the multiplication. These are the operations that we are looking at. However, we go on and we look at also what we call the roots. Roots and squares or powers, exponentials. All right. Operations with whole numbers and decimals, with and without a calculator. But we shall follow the word BODMAS. BODMAS, simply standing for, start with brackets, then order. Some other people say of, but it's the order. Then we have division, multiplication, There we come with addition, and we end with subtraction. In that order, you start with 1, 2, 3, 4, 5, then 6, in that order. For example, if you happen to have a solution, or if you happen to be asked to solve the equation below or the problem below, we shall say, for example, it could be 4 times 2 into brackets plus square root of 9. So bracket, what you look at, you come to your BODMAS. And number one, it has to look at brackets. You ask yourself, in the equation you're solving, do you have any brackets? If it's yes, then you start with the brackets. Yes, we have brackets here. So what is inside the brackets? The brackets tell us to multiply 4 times, which becomes what? 8 plus. So the brackets are gone. Order the square root. Do I have any other calculation? All right. If I had fractions, I would have solved the fractions before I continue. All right. So here it says order square root of 9, which is what? 3. So my final answer becomes 11. Right? This is example 1. What about example 2? If you have something like this, 4 minus 2 of 8 over 9 plus 16 divided by 4. Yes, look at this equation. It has a bracket, so you start with brackets, but that means it's 4 minus 2 of 8 plus, what's in the bracket? It's a 4. So having solved the bracket, what do we go on? Order, which is what? Of. So 4 minus 2 of becomes a multiplication plus 4. So these two here, you multiply them out. So it becomes 4 minus 16 over 4 plus 4. Remember, addition comes before subtraction. So you add. This is a negative number, so you're going to add these two. 4 plus the 4 here, which becomes 8 minus 16 over 9. This one gives us 72 minus 16 over 9. 72 minus 16 over 9. And you get your answer as this is 56 over 9. So this is the final answer. We are looking at BODMAS. Let's look at some solutions here, some questions. Use a calculator to find the square, cube. Okay. Square. What does this simply mean? Square, it means the number multiplies itself. The number times the same number. Example, we have the square of 4. We shall write it as, right, the square of 4. So simply meaning 4 times 4. And the answer becomes 16. Let's say the square of 6. This will be 6 times 6. The answer becomes what? 36. Answer becomes 36. So question number 1.1.1, they want you to say 1,5 times 1,5. 1,5 times 1,5. Which gives you 1.5 times, which gives you 2,25. Yes, you say that. Then 1.2. We're going to find out. So this one here becomes 16 plus 225 minus 9. So add the 2. When you add the 2, you end up having 241 minus 9. Minus 9, and the answer became 232. Let's go to question number 1.3. 1.3, we're going to follow the BODMAS straight away. Yeah, even here we follow the BODMAS because we began by adding, then we subtracted. Okay, do we have brackets? Yes, the first bracket wants you to subtract 6 minus 2. I'm looking at 1.3, so it becomes 4 plus 3 times another bracket. Get the answer from that. So I've removed the brackets now. So BODMAS says multiply before addition. BODMAS. So you're going to multiply first before you add. So it's 4 plus 21. And your answer becomes 25. Okay. Question number, operations with fractions. Now, here, what I want you to understand is that fractions will change. You can divide, we can add. You know, remember fraction, we have 3 types of fractions. We have a proper fraction, whereby we have a small numerator and a small denominator, numerator. Then the denominator. All right. Here, proper simply meaning the numerator is smaller than the denominator. That's a proper one. All right. A proper fraction, whereby we shall end up having, for example, like 7 over 10. This is a proper fraction. The number above is smaller than. So then we have what we call the improper. The improper, we shall say, we have a big numerator and a smaller denominator. All right. Example here, we could have a 7 over 3. This is improper. And it's from the improper that we get a mixed what? A mixed fraction. A mixed fraction. What I want you to understand is that a mixed fraction starts with a whole number followed by a numerator and a denominator. In this case, for example, if you see 7 divided by 3, this will be 1/4 over 3. This is how a mixed fraction will look like. So an improper fraction gives birth to a mixed fraction. All right, I want you to understand that fractions can also be divided, added, subtracted, multiplied, but there are some principles that we follow when we are doing that. All right. We are going to look at that. Doesn't matter whether it's a proper fraction or, but we have to look at it very fast and we see. When we are dealing with fractions, we are saying example one, sorry, addition. Addition of what? Addition of fractions. What will happen? For example, we have A over B plus C over D. The first thing, if you're looking for addition, you look for what we call the LCM, the lowest common multiple. So here, simple terms, it will be B times D. So which will come now, the D, this D will multiply with the A plus the B will multiply with the C. And you will get your answer, AD plus BC over BD. An example in addition of fractions, an example, we shall say, let's say 3 over 4 plus 6 over 7. This will be, we said we multiply B times the denominators. So here we can come. So this first place here, the 7 will multiply with the 3 plus the 4 multiplies with the exchange. So this will lead us to 21 plus 24 over 28. The answer here is 45 divided by 28. So this is your final answer. All right. This theory will also apply when we are subtracting. When you're subtraction of fractions. Subtraction of fractions. And this will also happen. We shall also look at the LCM, but the symbol changes the 1 4. We shall go straight into the example, the normal example. Example, let's say we have 10 over, let's say 24 minus 4 over 20, let's say over 8. You can multiply them, but these two have a lowest common multiple, which is 24. Because how do you get the lowest common multiple? You come here. We are looking for the LCM. Find a number that divides this and don't get a remainder. It's 8. 8 divides into 8 once, and 8 divides through that 3. So come here, we find 3. 3 into 1 can't, so it remains 1. 3 into 3, so the lowest, you multiply these two, which became 8 times what? 3. So it becomes what? 24. So the LCM, it's 24. So 24 goes in 24 once times 10 minus 24 goes into 8, how many times? 3. 3 times the 4, which is on top. So here we have 10 minus 12 over 24. Now, because you're subtracting a big number from a small number, you'll end up having a negative, and the answer becomes negative 2 over 24, whereby you can also minimize or simplify, which is negative. Okay. That is the answer there that we have. Let's continue and we look at, what about multiplication and division? Multiplication of fractions and division of fractions. We'll look at that very first. I'll show you what to do. multiplication of fractions and division of fractions. Same story. By the way, multiplication belongs to addition, whereas division belongs to subtraction in normal mathematics. Normal mathematics. That's what we do. All right, let me show you something small. What do we do when we are going to multiply? And what do we do when we are dividing? Now, we divide. What happens when you're dividing fractions? What happens when you're adding fractions? That's what we need to find out and see what happens. Now, when you're going to multiply, they multiply throughout, which will become, we are saying multiplication of what? Fractions. So we are saying if it's A over B times C over D, this will become A times C over B times D. So you multiply numerators alone and denominators alone. So we shall have the answers SC over BD. Example, we have 10 over 21 times. Now let's say, let me change it a little bit, sorry. Let's say 2 over 5 times 7 over 8. This will become 2 times 7 over 5 times 8. We are multiplying fractions. So the final answer here will become 14 over 40. You can simplify it. By 2, you get 7. And by 2, you get 20. Your calculator will give you that as simplified answer. Okay, so what about the division? Division of fractions. Division of fractions. Division of fractions simply meaning it's A, B divided by C, D. The division sign, it turns into a multiplication, and the fraction on your right hand side becomes the denominator becomes a numerator, and the numerator becomes a denominator. So the first one remains, then the symbol changes, then the denominator becomes the numerator, and the numerator becomes the denominator. Example. We have 6 over 7 divided by 3 over 2. So this goes straight. This first fraction remains, the one they are dividing. The symbol changes, the division sign changes. Then the numerator becomes a denominator, and the denominator becomes a numerator. And the answer goes on, and we say 12 over 21. By 3, you get 4. And by 3, you get 7. So the answer became 7. Sorry, 4 over 7. That's how we do it. Those are the principles. Let's look at ratios and rates. When we are looking, okay, we shall look at rounding, ratios, rates, percentages. This, you will see it as we go on. Okay, when we look at rounding off, let's start with rounding. Rounding, it's making the number shorter. Rounding, it's to make the number rounding off. You either round off to the nearest, or you round up. If not, you round down. Definitely down, you reduce, and up, you increase. Example. They are telling us round to the nearest uh, okay, round off to the nearest whole number. So remember, the whole number here, it's what? 34. So before we round off, the number where we're going to stop, we check the immediate number next to it. If it's 5 and above, that means you're going to pick 1 and we add to the number where we're going to stop, rounding off. Or if it's below, we don't do anything. We write the number. Now, here in our case, we have 34, 5. So these other numbers have to become zeros because if we are rounding off to the whole number. So before they become zeros, ask ourselves, this is 5. That means it also becomes 0 because I'm going to stop here. But I'll add a 1. So this one becomes 35, 000. So that's the whole number. Let's look at another example. Round to 3 decimal, we call them decimal places. They say round up to the 3 decimal places, meaning you're going to be left with 3 numbers after the comma. So for example, here we have it as 34, 5, 6, 8, 7. 3 decimal places. We are supposed to be left with 3 numbers after the comma. So this 7 has to go away. But 7 is greater than 5. What do? We add a 1 here. So our number becomes 34, 5, 6, 9. That's the number, rounding off. All right. If it was to 2 decimal places, sometimes you shall write it like this: 2 decimal places, simply meaning we should be left with 2 numbers after the comma. So it's 5. So 2 numbers after the comma, they are these ones here. So these ones have to turn what? 0, because I'm going to stop here. I need 2 numbers after the comma. So, because 8 is greater than 5, sorry, 8 is greater than 4, we add a 1, and the answer becomes 3, 4, 5, 7. 5, 7. That's the answer there, to 2 decimal places. Then we also have another rounding off to all numbers, to hundreds, to fives, to tens. For example, if they say round off to the nearest tens, nearest tens, and the answer is, sorry, the number is like this. The tens are these ones here. You see? So all these numbers here have to be zeros. So, but the 4 here, it's not, when it comes to tens, we have to exceed 5. So the 4 is below 5. So the answer here becomes 30,000. All right? Nearest tens. Hundreds, it will be 000 because we don't have hundreds here. Okay, they're telling us round off each number here to the nearest tens. So this became 90. This becomes 70. This becomes 50. Why is it 50? Because 5 has crossed half of 10. That's why it became 50. Here, these ones remain because this is 2. It's below 4. It's below 4. So this is it. Nearest tens. So nearest hundreds, we need to end at the numbers. So this one here becomes 300. Why is it 300? Because 8 is greater than 4. So we add a 1 onto 2 and becomes that. This becomes 900. this becomes 700 to the nearest hundreds. The rounding up and rounding down, that one is seen on the slips. On the slips, when you buy, they're supposed to give you some cents, but they cancel them out. And the reason why they cancel them out is because we no longer have 1 rand. Sorry, 1 cent. We no longer have 1 cent. Okay. Let's look at these numbers here. Round off to the number of decimal places indicated, as indicated. So the first one, they're telling us to 3 decimal places. So the number is 67,9845. By the way, the numbers after the comma, we read them the way they are. It's 9845. We don't say 9,800. Comma 9845. The number, you read it the way it's supposed to be. But they told us to 3 decimal places. So you come here, say 3. So that means this one goes off, becomes a 0. But before it becomes a 0, ask yourself, is it greater than 5 or is it 5? Yes. That means you add a 1 onto this. You add only to the immediate number, not everywhere. So here the answer becomes that much. We look at question number 2.2. Round off 0,8157 to 2 decimal places. That means we are supposed to remain with 2 decimal places. These numbers here will have to die into zeros. They die into zeros. And the question becomes 0 into, so this is 5. So we add a 1 onto the 1, becomes 2. All right. So we go to 2.3. 2.3 to want us to 1 decimal place. And 1 number after the comma. This is how the number looks like. So 1 number after the comma. That means the rest have to go off. They need to be cut off. So they become zeros. So before they become zeros, so this is 8 greater than 5. So you add a 1 here. So your final answer became 4,1. So question number 2.4. 2.4. 2.4, it's 5,8999. And the answer becomes, it's asking us to round off to the nearest. It's asking us to round off to the nearest. It wants us to round off to the nearest. It wants us to round off to the nearest. Sorry, to 2 decimal places. So meaning 2 numbers after the comma have to remain. So it becomes 5, comma. Now, these ones have become zeros. You pick a 1, add it onto, but then when you pick a 1 and 89 plus 1, you get 90. So this will become 90. Question number 2.5, finally, the last one. All right. We are looking at 2.5, this 2.5. It's 7,9895. To what? To 3 decimal places. When you write like this, we mean they did this 3 decimal places. So 3 numbers after the comma, the 5 has to go off. So this will become 7,9. Now, if you add 1 onto this, becomes 10, becomes 9. It's, please, the number that's going to be there, it becomes what? A 0. That's how we do rounding off. We continue and we look at the format numbers. What does a dozen mean? A dozen stands for 12 items. 1 year has how many days? It's either 365 or 366. A year with 366 is called a leap year. And in this year, the February goes to 29 days. All right. February of a leap year goes to 29 days. But the normal February is 28 days. All right. Then A decade. A decade, these are 10 years, a collection of 10 years. A century, a collection of 1,000 years. Then if you collect 1,000 years, you have what we call a millennium. 1 over in cricket, these are 6 balls, like one has balls, like bowling, throwing 6 balls. Okay, those are the terms, right? That means half a dozen becomes half a dozen, it's 6. Half a dozen is what? 6. In a hotel, your room is 214. What does this mean? It simply means you're going to 2 is for the second floor, then room number 14. So this is the 2 and this is the 14. All right. Your flat number in the block of flats, it's 1223. This would mean it's on the 12th floor. Then becomes room 23, sorry. Question number 1.4. 1.4, it says, Jen buys 18 eggs. How many dozens of eggs did Jen buy? She bought 1 dozen and 6 eggs. Because 1 dozen equals to 12. So there are 18. We're remaining with 6 what? Eggs. So she bought 1 dozen and a half. A dozen, 1 dozen and a half. So the answer is supposed to be 1 dozen and a half. Otherwise, we would have said 18 divided by 12, where we get a whole number and a half. 18 divided by 12 is same as 3 over 2. By 6, you get 3. By 6, you get 2. Okay, so she bought 1.5 dozen. Let's look at ratios. Ratios, we use them when we are comparing units. Sorry, when we are comparing quantities. We use ratios when you are comparing quantities with the same units. Comparing quantities with the same units of the same units. What do we mean by that? For example, juice and water. They are both in liters or centimeters what? Cubed. They are the same units. All right? They are the same units. And ratios are written as, for example, a certain number is to a given number. Then if a ratio starts with 1, we call it a unit ratio. A unit ratio. Ratios, we can use them to increase or decrease in a particular way. Let me give an example here. If 4 friends, these are 4 friends, they want to open up a business. 4 friends want to open up a business worth let's say 12,000. But friend A is going to bring 2 parts. Friend B will bring 3 parts. Friend C brings 1 part. Then friend D brings, let me see, 2 parts also. You understand? Remember, 2 parts of the 12,000. So what do we do? For us to find out how much A will bring, how much B will bring, we shall have to add up their shares. So we shall say 2 plus 3 plus 1 plus 2. So you end up having, this is 4, 7, 8. So they have, all in all, it's 8 shares. So we shall come here and say, no, of the 12,000, 12,000 is going to be divided into 8 shares. So the first one is going to be 2. So this becomes that much. That means it's going to bring, this is for, the first person is going to bring 3,000. A. What about B? B will say 12 also over 8 times what? 3. 4 over A, let's say, which will become 4,500. So this is the value for B. Then friend C, for him, he said he wants to bring this much. Sorry, times the 1. And this person will contribute 1,500. Then lastly, D will contribute the same as A, 3,000. And when you add up these amounts, have to add up to the amounts that we are talking about. So this and that's 6,000. Also, this is 6,000. You see that it comes back to, but it's a contribution from different people. Why doesn't it have units? Because the units cancel out. Let's look at this. These ratios that we have here. Actually, it can also be written as equivalent fractions. What are equivalent fractions? These are same, or what would we say? They are the same fractions. They have equivalent fractions that will lead us to simplified fractions. All right. Equivalent fractions lead us to simplified fractions. I'll show you now what's meant by I'll show you now what's meant by equivalent fractions. For example, 10 over 20 is the same as 5 over 10, which is the same as 1 over 2. So these are equivalent fractions. 10 over 20 is the same as 5 over 10, the same as 1 over 2. Simplified fractions. Okay, yeah, write 2 equivalent ratios to the following ratios. 2 equivalent. So now we have 4 is to 5. You can decide to multiply them, which will become 4 is to 5. It's the same as 8 is to 10, which is the same as 16 is to 20. You see that? These are equivalent ratios. All I did, I got 2. I multiplied 2 by the side. Again, for the second one, I multiplied through by 4. So this one here gives me this. And this, when I multiply by 2, I end up having this. All right, then we look at part B. This is A. Part B, we have 2 into 7. Still, what you do on one side, you do it on the other. You can multiply it, so you have it's the same as, or the same as. All right, that's how we do the equivalent fractions. Whereas C, 15 is to 25. This could be the same as 5. 3 is to 5. 3 is to 5. When you divide through by 5, 3 is to 5, or the same as the 18 is to 30. It's the same fraction that you, same number that you will get. Okay, we'll go to the next question. The next question looks at ratios, but in form of mixing and in word form. It says if cement, sand, and stone have to be mixed in a ratio of 1:2:3 to make high strength concrete, how many wheelbarrows of sand and stone should be mixed with 5 wheelbarrows? So here we go, 5 wheelbarrows. So how many wheelbarrows of sand, stone will be mixed? So simply meaning, because they're telling us if you only have 1 cement, you'll have 2 for sand, and you have 3 of stone. So here we have 5 wheelbarrows of cement. That means it will increase by becoming 10. And so they're asking how many. So for stone or sand, we shall have 2 times what? 5, which becomes 10 wheelbarrows. And for stone, we shall have 5 times, which become 15 wheelbarrows. Wheelbarrows. So 1.4. There are 143 girls and 91 boys in the school. What is the ratio of boys to girls? Simplified, they're asking us boys to girls. Take note of that. So we shall have 91 is to 143. 91 is to 143. Hmm, 91 divided by 3. Let's see. It can't be. 91 divided by 1. Yeah, this is the format that we have. Okay, those are ratios. Again, we continue and we see if there were 24 red and blue Smarties in a box, and they are in a ratio, blue is to red, which is 1:3 respectively. How many red Smarties are in the box? Ask yourself. There are 24, but the division here, it says blue is to red. 1:3, which means the total is what? 4. So of these 4, 3 of the 4, 3 are red times 24. So this will become 18 red Smarties. In a packet of sweets, in a packet of sweets, there are 36 sweets. 2 kids, John and Anthony, want to divide the sweets in a ratio of 3:4. How many sweets will each get? Now, a ratio. That means this one, if John gets 3, Anthony gets 4. If John gets 6, Anthony gets 8. You understand? So let's see. We are going to share the sweets. So all you are going to do, get the ratio, add it up. You get the answer 7. So we shall say out of 7, John has to get 3. So it will become This is 108 divided by 7, whereby we have 15,42. But remember this, you can't have a half a street. So this is approximately 15. Then Anthony will get 4 out of 7 times 36. $144. So you see, this is 20,5. 5 is already above. So this one makes it what? 21. So Anthony gets 21 streets and Johnny gets 15. We round up and we round down. Here I had to round down because this was less than 5. Here it's above 5. So I rounded it up. Here I rounded down. Why do we round out with whole numbers? Because you can't have a half a street. We need whole streets. Okay. It's already done. Yes, let's look at rates. Ratios. Let's recap. Ratios, we said we look at the same what? Units. Then rates, they look at different what? They look at different units. Different units. So if ratios are for the same units, that's why we don't have units on ratios, but rates are different units, and we shall see it. An example, it's the one for speed. Speed, we are looking at a distance over time, which the units for distance is kilometer, and the time, these are what? Hours. That's why you see at the end of the day, we say kilometers per hour. Kilometers per hour. These are rates. Another thing where we see rates, it's where, for example, cost per item. Cost per item. This will be rand. For example, if it was in kilograms, it would be rand per kilogram. Could be rand per tin. You know, these are rates. The moment we change or we compare units that are different, two different units. Okay, we look at the other question, which is we look at percentages, and I want you to understand that percentages, we look, percent actually, it means out of 100. And the final answer or the symbol is what? 2 eyes and a stroke. Now, when we're calculating percentages, if we want you to turn or converting fractions, because usually we need to have a fraction and we multiply it by 100. The answer we get is a percentage. Example, 40 out of 50 as a percentage. This will become 80%. So simply meaning 80% of 50, it becomes what? 40. Wow, how did I do this? It's 80 over 100 times 50. This dies with that, you remain with that 2 down here. So 80 divided by 2, you get what? 40. All right, that's when they ask you to change a fraction into a percentage out of 100. Write it as a percentage. Write it as a percentage. Okay, the other question that we shall look at, how do we express percentages of given values? Percentages of given values. Now, percentages of given values, for example, the one we have inside here, it says 10%. Now, this simply means it's going to be 10 out of 100. This symbol here, 10%, means it's 10 out of 100. Multiply with the value. And when you multiply with the value, you'll end up having 150. 25. 25% of 2,545. What answer will it be? 25, 25 divided by 100 times 2,540. So here the answer becomes 636,25. So it's 636,25. That's the answer there. Then we look at 60% of 11,914,216. So this one will be 60 over 100 times 11,94216. So this one simply means we have it as 7,148,529,6. That's the answer there. We look at this word solutions or word problems. They're asking, or they're telling us 75% of the money raised at a school fundraiser will go to charity or charity. If the total of the funds raised was 20,000, if the total raised was 20,000, if the total raised so we shall look for 75% of this amount of money. So it will be 7 times you understand? So we're looking for how much will be given to the charity or how much will go to the charity. And we're looking at an amount of an amount of 15,411 rands. 411 rands. Now they're telling us 2.6. Out of 64,100 available tickets, 60,895 were sold. Determine the percentage of tickets that were sold. So simply meaning they sold over the total tickets, the total number of tickets out of 64. So out of, so meaning this is out of this number here is out of this. As you're looking for fractions, please, a bigger number should be lower, should be the denominator. A bigger number should be the denominator. And we have 60,895 divided by 64,100. You multiply by a fraction. So we are looking for the percentage, and the answer became 95%. Yes, percentages. Percentages can be used to increase or decrease. Increment, we see this in salaries, whereas decrease, increase in salaries or prices. It has increased by 2%. Then this one also, yeah, we also see this in discount. I want to teach you one thing. When you're increasing, please always take 100 plus the percentage at which you're going to increase with, divided by 100 again, times the number you are increasing. Times the number that you are increasing. Then when it comes to discount simply means it's going to be reduced. So what I want you to do is to be always 100 minus the percentage at which it's decreased over 100 times the number that is being decreased. Times the number that's being decreased. We shall do an example here. Example. Increase 800 by 20%. So what did we say? It's 100 plus the percentage you're increasing with over 100 times the number that you are increasing, which became 1,2 times 800. And I believe it's 900, 960. It's 900 and what? 960. Okay, that's it. Then even the other method of use that you know already from grade 7, it's fine, whereby you first look for the percentage, then you add it on after. It would also work. All right, let's do this other one here. Example for discount. Let's say 1,000. No, let's say 4,100. It was reduced by 20%. Simply meaning 100 minus the 20 over 100 times the value that you are reducing. So this became 0.8 times reducing. And some common sense has to apply. You cannot reduce and you get a number more than the number that you had. All right, and you cannot increase and you get a number below the amount that you are increasing. This happens most times, but please take note of that. All right, we shall look at some things here, and we see determining the original value. Determining the original value, this simply means going back to the value that was either decreased or increased. The value that was increased or decreased. Now, listen to one thing. They say a value was increased by 25% and it became it became 1,750. So they ask you determine the value before the increase. So determine the value before the increase, simply meaning what you're going to do, you know it very well that, you know what, there's a certain value that was increased by 25. So how did they do it? They took 100 plus 25 over 100, and they got their answer as, you see? So having got this answer, they multiplied that value. I'm calling it Q, or let me use an empty box. They multiplied that value, and they ended up having 1,750. So if the number was multiplied by 1,25 and they got the answer, so what would be the answer? So we shall divide through by. So we shall get the answer there. So the original value was 1,400. This is how we get there. That's why I want you to learn this kind of method, because it will make your life easy. Because if you use the other one, it will take a long step and some people can't even remember it. All right, let's look at another example here. The original value was reduced by 20%, and it became 1,200. So determine the original value. Determine the original value. So simply meaning, we shall use the same method. Allow me use the green, and I will do it here. So the number was reduced. That means 100 minus 20 over 100, which is what? 80 over 100. This in decimal format is the same as what? 0,8. So it was 0,8 times a given number, and the answer became 1,200. So we divide through by 0,8, divide through by 0,8. This goes with that. The box becomes 1,000. Remember, the number is bigger than the one because it was reduced. So it was 1,500 that was reduced by 20, and the answer became 1,200. Thank you very much. Let's meet next time.